When sizing a generator for an existing building and the connected emergency lighting loads are unknown, a common estimation method involves using a volt-ampere per square foot value. A typical value employed for this purpose is 1/3 volt-ampere per square foot. This estimation provides a reasonable basis for determining the emergency lighting load contribution to the overall generator size requirement. This method offers a practical approach when specific emergency lighting circuit details are not readily available. To determine the total emergency lighting load, multiply the building square footage by the 1/3 volt-ampere per square foot factor. This yields the estimated volt-ampere requirement for emergency lighting. This volt-ampere value can then be used in conjunction with other known or estimated loads to calculate the total generator size needed. It is important to note that local codes and regulations may specify different volt-ampere per square foot values or mandate specific emergency lighting requirements. It is imperative to consult and adhere to all applicable codes and regulations when determining emergency lighting loads and generator sizing. The 1/3 volt-ampere per square foot method serves as a general guideline, but compliance with local requirements is paramount. Consider the types of emergency lighting fixtures being used. Light-emitting diode, or LED, fixtures are highly energy efficient and may allow for a reduction in the estimated volt-ampere per square foot value. However, it is crucial to verify that the chosen value complies with all applicable codes and regulations. If the building has areas with particularly high lighting requirements, such as stairwells or exit corridors, these areas may warrant a higher volt-ampere per square foot value to ensure adequate illumination during emergencies. Conversely, areas with minimal lighting needs may justify a lower value. Documentation of the calculations and assumptions made is essential for demonstrating compliance with codes and regulations and for future reference. Maintain detailed records of the building's square footage, the volt-ampere per square foot value used, the resulting emergency lighting load calculation, and any other relevant information. Consider the building's occupancy type when determining the appropriate volt-ampere per square foot value. High occupancy buildings, such as hospitals or schools, may require more stringent emergency lighting requirements than low occupancy buildings, such as warehouses or storage facilities. If the building has a fire alarm system, the emergency lighting system may be integrated with the fire alarm system to automatically activate the emergency lights upon detection of a fire. This integration can further enhance safety and ensure that emergency lighting is provided when needed. The emergency lighting system should be designed to provide adequate illumination for a specified duration, typically 90 minutes or more, as required by code. The generator must be capable of supplying the emergency lighting load for the entire duration of the required backup time. Periodically inspect and test the emergency lighting system to ensure that it is functioning properly. Regular maintenance and testing can help identify and address any potential issues before they become major problems. Consult with a qualified electrical engineer or contractor to ensure that the emergency lighting system is properly designed, installed, and maintained. A professional can provide valuable expertise and ensure compliance with all applicable codes and regulations. Consider future expansion or renovation plans when sizing the generator. If the building is likely to be expanded or renovated in the future, it is prudent to account for the increased emergency lighting load that may result. This can help avoid the need to upgrade the generator in the future. Consider the ambient temperature in the area where the generator is located. High ambient temperatures can reduce the generator's output capacity. It is important to direct the generator's output accordingly to ensure that it can supply the required emergency lighting load under all operating conditions. Consider the generator's fuel source and availability. The generator's fuel source, such as diesel or natural gas, should be readily available and reliable. Ensure that there is an adequate supply of fuel on hand to power the generator for the duration of the required backup time. Consider the generator's maintenance requirements. Generators require regular maintenance, such as oil changes and filter replacements, to ensure that they operate reliably. Develop a maintenance schedule and adhere to it diligently to prevent unexpected failures. Consider the generator's noise level. Generators can be noisy, especially when operating under heavy load. If the generator is located in a noise-sensitive area, it may be necessary to install sound attenuation measures to reduce the noise level. Consider the generator's emissions. Generators can emit pollutants such as nitrogen oxides and particulate matter. If the generator is located in an area with strict air quality regulations, it may be necessary to install emission control devices to reduce the emissions. Consider the generator's cost. Generators can be expensive to purchase, install, and maintain. It is important to carefully consider the cost of the generator and to balance it against the benefits of having a reliable backup power source. Ensure that the generator is properly grounded to prevent electrical hazards. Grounding is a critical safety measure that helps protect people and equipment from electrical shock. Ensure that the generator is protected from the elements. The generator should be located in a weatherproof enclosure to protect it from rain, snow, and other weather conditions. This will help prevent corrosion and other damage that could impair the generator's performance. Consider the generator's automatic transfer switch, or ATS. The automatic transfer switch is a device that automatically switches the building's electrical load from the utility power to the generator power in the event of a power outage. The ATS should be properly sized and installed to ensure a seamless transition between power sources. Consult with the local utility company to determine any requirements for connecting the generator to the utility grid. Some utility companies require generators to be synchronized with the grid before they can be connected. This synchronization process can be complex and may require specialized equipment. Ensure that the generator is installed in accordance with all applicable codes and regulations. The installation should be performed by a qualified electrician or contractor who is familiar with local codes and regulations. Consider the use of a load management system to reduce the emergency lighting load. A load management system can selectively shed non-essential loads to reduce the overall load on the generator. This can allow for a smaller generator to be used, which can save money on purchase and installation costs. Consider the use of dimmable emergency lighting fixtures. Dimmable fixtures can be dimmed during normal operation to save energy and then automatically brighten to full intensity during emergencies. This can help reduce the emergency lighting load and improve energy efficiency. Consider the use of occupancy sensors to control emergency lighting in infrequently used areas. Occupancy sensors can turn on the emergency lights only when someone is present, which can save energy and extend the life of the lighting fixtures. Ensure that the emergency lighting system is designed to provide adequate illumination for people with disabilities. The Americans with Disabilities Act, or ADA, requires that emergency lighting systems provide adequate illumination for people with disabilities, including those who use wheelchairs or have limited vision. Consider the use of a battery backup system for emergency lighting. A battery backup system can provide emergency lighting for a limited duration in the event of a power outage. This can be a cost-effective alternative to a generator for small buildings or areas with low emergency lighting loads. Ensure that the battery backup system is properly sized and maintained to provide the required backup time. Consider the use of uninterruptible power supply, or UPS, for critical emergency lighting loads. A UPS can provide continuous power to critical loads, such as exit signs and emergency communications systems, even during a power outage. This can help ensure that these critical systems remain operational during emergencies. Ensure that the UPS is properly sized and maintained to provide the required backup time. Consider the use of a hybrid emergency lighting system that combines a generator, a battery backup system, and a UPS. This type of system can provide the most reliable and flexible emergency lighting solution. The generator can provide long-term backup power, the battery backup system can provide short-term backup power, and the UPS can provide continuous power to critical loads. Ensure that the hybrid system is properly designed and integrated to provide seamless transitions between power sources. Consider the use of a remote monitoring system to monitor the emergency lighting system. A remote monitoring system can provide real-time information on the status of the emergency lighting system, including battery voltage, generator output, and lighting fixture performance. This can help identify and address any potential issues before they become major problems. Ensure that the remote monitoring system is properly configured and integrated with the building's management system. Ensure the emergency lighting is tested periodically per code. Perform the monthly and annual testing to make sure the components are operational and ready for any outages that may occur. Also, remember to document all the emergency lighting records per code. Make sure they are available for inspection.